Hello. The next topic to discuss during this lecture is types of tests and when we apply them. So previously we used statistical tests for analyzing whether betas are statistically significant to interpret results of the post-estimation tests, but actually statistical tests are applied in many fields. Sometimes you do not have enough data in order to design an econometric model and account for all the potentially important factors. So in this case, a statistical test can still provide some valuable insight into the links between the variables of interest. So there are two basic types of statistical tests, parametric and non-parametric. And depending on your purposes and the character of your data and sample, you are expected to choose the appropriate one. So first of all, parametric tests are for normally distributed data. And non-parametric tests are for data with non-normal distribution. The reason behind it is that parametric tests concentrate on comparison of mean values, average values, and non-parametric tests concentrate on the analysis of median values in the samples. So that's why parametric tests require normally distributed data, and for non-parametric tests, even non-normally distributed data can be used. Parametric tests are for continuous data like GDP per capita, GDP growth rate, weight, level of IQ, and so on and so forth. So you should be able to remember what the continuous data is from the first lecture. And non-parametric tests are for ordinal and ranked data. Again, if you do not remember this, please go back to the first lecture. So ordinal data are, for instance, number of stars in a hotel's ranking. So 2 is better than 1, 3 is better than 2, but it's not possible to say that 4 is 2 times better than 2. There is no such dependency. Parametric tests actually allow for different variability and dispersion in the data sets, and non-parametric tests require the same variability. We will not concentrate on this feature that much, but it's still important. Parametric tests are less tolerant to small samples, so you are likely to obtain statistically insignificant results using parametric tests when your sample is small, and non-parametric tests are more tolerant to small samples. So that's why parametric tests are usually used when you have large massive of data, like when you perform some extensive research and you collect many observations, then it would be appropriate to use parametric test. However, when your sample is relatively small, then it's better to use non-parametric test. So just to make a conclusion, you use parametric test when your sample is big enough, when variables are continuous, and when distribution of variables is normal. You use non-parametric tests when the sample is rather small, when variables are ordinal, and when the distribution is non-normal. So I would just like to show you briefly how you analyze whether distribution of the variable is normal. So first, of course, you have to upload the dataset to Gretel as usual. Then you can pick the variable of your interest. So this is the stock of capital, again from neoclassical model of growth dataset. And I want to check frequency distribution. So I specify 100 beans, and I want to test against normal distribution. So this is the result. As you can see, as you remember, for Jark-Barrett test for normality, zero hypothesis is that data is normally distributed. In our case, p-value of the test is less than 0.05, which means that distribution is not normal. So actually, it's a good idea to provide some initial analysis for the data before you estimate econometric model or before you perform any kind of statistical tests. So actually, this is called descriptive statistics. A bit later, we will discuss how to do this in Gretel and how to interpret the results of descriptive statistics in order to indicate some potential biases in your regression model. But when it comes to introduction to statistical tests, that was it. Thanks for your attention. Hope you enjoyed this video and see you in the next one.